Chapter 21. Concluding Observations. In the preceding pages, it has been my object to convey a general idea of the mineralogical structure of Sussex, confining myself, so far as the nature of the inquiry would permit, to a plain statement of facts, and but seldom indulging in hypothetical discussions. I cannot, however, close this volume without taking a more extended view of the subject, and briefly noticing the principal phenomena that have been submitted to our examination, endeavor to point out the geological deductions that result from their investigation. The chalk formation has been described as traversing the county in a direction nearly east and west, extending from Beachy Head to near Midhurst, from whence it passes into Hampshire, and finally into Surrey and Kent, terminating in a range of lofty cliffs at Dover, thus forming a semi-elliptical chain of downs that encloses an extensive district composed of deposits more ancient than the chalk. On the south and southeast, these strata are cut off by the British Channel, and the southern margin of the chalk is covered by the remains of the tertiary formations of the Isle of Wight Basin. The area included by the chalk has a range of hills belonging to the iron sand in the centre, the Forest Ridge, on each side of which the country gradually descends. The low district on the southwest, forming the Weald of Sussex, and that on the northeast, the Weald of Kent, both being composed of the Weald clay with its beds of shelly limestone. In Kent and Surrey, a range of hills formed by the green sand intervenes between the Weald and the foot of the downs. But in the southeastern part of Sussex, this deposit only constitutes a ridge of inconsiderable elevation. Intermediate between the hills of the green sand and the chalk is another valley, formed by the outcrops of the grey and blue chalk marl. The annexed diagram and section, although possessing no pretension to accuracy of detail, will serve to render this description more intelligible. The figures, both in the plan and section, refer to the same deposits. The section is in the direction of a line drawn from the south of Sussex to the north of Kent. Explanation of the plan and section. 1. Tertiary formations, plastic clay of Newhaven. 2. Chalk, constituting the South Downs of Sussex, the Surrey Hills, and the North Downs of Kent. 3. Grey and blue chalk marl at Ringmer near Lewes, on the north of the South Downs, at Bletchingley in Surrey, and Folkestone in Kent, on the south side of the North Downs. 4. Green sand and Cherty sandstone at Eastbourne, south of Lewes, Ditchling, Haslemere, etc., in Sussex, near Godalming, Reigate, Nutfield, etc., in Surrey, Folkestone and Hythe in Kent. 5. Weald clay, containing Sussex marble, Wealds of Surrey, Sussex and Kent. The localities of the limestone in Sussex are well known. In Surrey it occurs at Red Hill, near Reigate, and in Kent, at Bethersden. 6. Iron sand, with beds of bivalve limestone, forming the central range of hills on the boundary line of Kent and Sussex. 7. Tilgate limestone, etc. The plan shows the appearance of the strata on the surface, and the manner in which the various formations are disposed in regular succession within the area encircled by the chalk hills, arranging themselves round the central mass of iron sand. Hence, in the section from New Haven to the Forest Ridge, the deposits form a descending series, and are inclined towards the south. Thus we have 1. The plastic clay, 2. The chalk, 3. The blue chalk marl, 4. The green sand, 5. The wheeled clay, and 6. The iron sand. But proceeding from the Forest Ridge to Dover, they are passed over in an ascending order, and dip in a contrary direction, the iron sand being the first, which is succeeded by the wheeled clay, green sand, blue chalk marl, and chalk. Such is the geographical distribution of the strata in Surrey, Kent, and Sussex. And it is worthy of remark that the formations on the opposite coast of France are disposed in a similar manner, appearing like a continuation of the English beds. The escarpment of the French chalk describes a semicircle of about 12 miles radius, ranging around Boulogne as a centre. The southern extremity on the coast near Etaples, corresponding with the termination of the Sussex Downs at Beachy Head, and the northern point at Calais with that of the Kentish Hills at Dover. The included area contains beds of green and iron sand, but the greater part of the coast is composed of a calcareo-agricelous formation, which underlies the sand last mentioned, and is considered by Professor Buckland as identical with the Oxford clay. This occurrence of the more ancient deposits within a zone of chalk hills is a problem exceedingly difficult of solution. From the appearance of the strata, as shown in the plan and section, one might be almost led to suppose that the chalk, at some remote period, was continuous over the whole extent of the country that now forms the counties alluded to, and that by some unknown catastrophe the central mass of chalk had been swept away, and the underlying deposits forced into their present situation. I do not, however, mean to insinuate that such has actually been the case, but that the mode in which the strata are disposed presents such an appearance. For although, as an eminent geologist has remarked, the truncated form of the escarpment of the chalk evidently shows it to have once extended much farther than at present, still it would be highly rash to assume that at any period it actually covered the whole space in which the inferior strata are denuded. We shall now proceed to take a rapid sketch of the geological features of the several formations previously described, that their most important characters may be placed in a conspicuous point of view. 1. The iron sand, page 24, requires but a brief notice. It has been shown to consist of various strata of sand and sandstone, including beds of ironstone, page 28, Shelley limestone, page 30, and coal, page 34. The limestone bears a considerable resemblance to the upper beds of the Purbeck, and is supposed to form the base upon which the iron sand rests. Yet there is reason to conclude that in some instances, page 33, these deposits alternate. The shells enclosed in the limestone are wholly bivalve. Some resemble a species of Telina, or nucula, and others are supposed to belong to the genus Sirene. But whether they are of freshwater or of marine origin has not been satisfactorily determined. The beds of coal appear to be of very limited extent, and not likely to be sufficiently productive for economical purposes. Their occurrence in such a situation is, however, highly interesting to the geologist, and proves how much the existence of a deposit may depend upon local causes. The organic remains are but few. Traces of lignite or charred wood occur in the iron sand, impressions of ferns in the coal shale, and the casts and remains of bivalves in the limestone. Two, Tilgate limestone, etc., page 37. The strata designated by this name are fully described in the body of the work. In this place it is only necessary to recapitulate the more important points. These deposits consist of thin beds of limestone and sandstone, which repose on blue clay, and correspond in so many particulars with the Purbeck, that there is every reason to conclude they belong to that formation, and form a protrusion through the iron sand by which they are surrounded. See page 58. They contain the remains of 4 or 5 species of vegetables, bearing a distant resemblance to recent tropical plants, 9 or 10 kinds of univalves and bivalves, several genera and species of fishes, 3 species of turtle, and 1 or more gigantic animals of the lizard tribe, besides the bones, teeth, etc. of unknown animals, and perhaps of birds. The remains of turtles, fishes, lizards, etc. occur in the Purbeck limestone, and the latter also corresponds in its chemical characters with that of Tilgate. It therefore appears unnecessary to renew the discussion on their supposed identity, and I shall only remark that the fossils collected since the former part of this volume was written serve to confirm the opinion therein advanced. 3. The wheeled clay, page 61, is characterized by the Sussex marble, which has commonly been supposed to be of freshwater origin, from the presumption that the univalves it contains are related to the recent Helix vivipara. But if the observations of Mr. G. B. Sowerby, see page 67, are correct, and his opinions on the subject are entitled to considerable deference, the hypothesis is untenable, since he believes that the shells in question possess neither the form nor structure of freshwater shells, but bear a close resemblance to a species of marine turbo, allied to T. litorius. 4. The green sand, page 69, with its beds and concretions of cherty sandstone, exhibits considerable variety, both in color and in the nature of its materials. It is, however, clearly identified with the chlorite sand of Wiltshire by its organic remains, consisting of more than 20 kinds of fossil shells, most of which also occur in the same deposit in Devonshire and Wiltshire, page 78. In some instances, the sandstone is strongly impregnated with bitumen, page 76. In others, it contains fragments of petrified wood, page 76. 5. The blue chalk marl, or gault, page 80, is a remarkable division of the chalk formation, and although not always present, yet wherever it does occur, maintains a striking uniformity. both in its mineralogical characters and organic remains. It contains 2 or 3 species of Turbinolia, more than 30 kinds of Testaceae, which in most instances retain their shelly coverings in a beautiful state of preservation, 5 species of Crustacea, and the scales, teeth, and vertebrae of fishes. Many of these fossils are peculiar to this deposit, namely Turbinolia conigi, Cirrus plicatus, Rostellaria carinata, Nautilus inequalis, Ammonites splendens, Hamites attenuatus, Nucula pectinata, Inoceramus concentricus, Inoceramus sulcatus, etc., and the Crustacea. The Malin Rock of western Sussex, page 84, is evidently a continuation of the same bed, but somewhat altered in its characters by the influence of local causes. 6. The grey chalk marl, page 99, is coextensive with the chalk, appearing throughout the county, on the inner edge of the escarpment of the downs. Its organic remains are very numerous. Those discovered in the vicinity of Lewes consist of wood, supposed Julie of the Larch, impressions of leaves, 7 kinds of zoophytes, several species of echinites, upwards of 50 species of univalves and bivalves, and the remains of fishes and crustacea. Of these, the scaphites, turrilites, hamites, and the supposed Julie are the most remarkable. 7. The upper and lower chalk, pages 139 and 143, form the South Downs. Their characters are too well known to require farther notice. They contain wood, impressions of supposed vegetable bodies, nearly 30 different kinds of zoophytes, starfish, 15 species of echinites, or more kinds of 50 species of univalves and bivalves, 4 species of crustacea, 18 or more kinds of fishes, and the remains of a species of monitor. The strata comprised in the preceding sketch have manifestly, with but few exceptions, been formed by gradual deposition at the bottom of tranquil seas, the zoophytes and shellfish having in all probability been enveloped while living in their native beds. It is also evident that these formations took place at periods sufficiently remote from each other to allow of the consolidation of the inferior beds before the upper ones were deposited, the line of separation being always distinctly marked, and the inhabitants of each formation essentially differing from those contained in the strata either above or below it. 8. The tertiary formations have been described, page 250, as lying in a basin or hollow of the chalk. Hence it is obvious that the latter must have suffered considerable destruction subsequently to its consolidation, and the immense quantity of rolled chalk flints that occur in the plastic and London clay not only confirms that supposition, but also tends to prove that a considerable period must have intervened between the deposition of the chalk and that of the strata under consideration. The beds comprehended in this division are the Druid sandstone, plastic clay, and the London clay, and sandstone. The Druid sandstone, page 253, appears to have anciently extended over a considerable portion of the English chalk, but now only occurs in the state of large boulders, which in most instances lie bare on the surface of the downs. It is supposed that this sandstone did not form a continuous bed, but was originally embedded in sand, like the masses of Winston in western Sussex. See page 71. It is destitute of organic remains. The plastic clay, page 256, consists of various beds of marl, sand, clay, and gravel, the lowermost constituting a ferruginous breccia, which lies immediately on the chalk. Castle Hill, near Newhaven, and Chimting Castle, east of Seaford, are the principal localities of these deposits in Sussex. This formation contains aluminite, crystallized sulfate of lime, surturbrand, wood, the impression of the foliage of a species of platanus, fruit of the palm, shells of the genera Cerithium, Helix, Mactra, Unio, Cytherea, Cyclus, and Austria. A shell which is supposed to be a freshwater bivalve, page 264, and the teeth of a species of shark. The analogues of these beds appear on the opposite coast near Dieppe, where strata of sand, sandstone, and plastic clay are seen lying upon the chalk, page 266. The London clay, page 267, is confined to the southwestern part of the county. At Bracklesham it abounds in fossil shells, which exactly correspond with those of Hordwell in Hampshire and Grignon near Paris. Nearly 40 species have been discovered. The limestone constitutes several groups of rocks near Bognor and Selsey, page 271, and appears to be decided analogous to the calcaire grossier of Paris. It contains nearly 20 shells peculiar to that deposit. These tertiary formations closely correspond with the lower beds of the Paris basin, and are without doubt detached portions of a series of strata, deposited under similar circumstances in that excavation of the English chalk, which geologists distinguish by the name of the Isle of Wight Basin. Here, then, we have undeniable proofs of another deposition of regular strata, formed by a sea in a state of tranquillity, having been broken up and almost annihilated by some sudden and powerful catastrophe. 9. The diluvian accumulations of sand, gravel, clay, pebbles, etc., page 275, promiscuously distributed over the surface of the country, and occasionally including the remains of elephants and other land quadrupeds, page 283, afford also conclusive evidence that some general eruption of water has taken place subsequently to the deposition of the most recent of the regular strata. To the same cause may likewise be ascribed the present form and appearance of the surface of the earth, the rounded outlines of our hills, and the valleys, combes, and sinuosities by which they are intersected. For if there be any one fact thoroughly established by geological investigations, it is the circumstance that our globe has been overwhelmed at a comparatively recent period by the waters of a transient deluge. From the facts that have been presented to our notice, the following inferences naturally arise. Firstly, that the strata composing the county of Sussex have been formed at different periods by successive depositions at the bottom of tranquil seas. Secondly, that the waters which deposited these formations were inhabited by shellfish, zoophytes, fishes, etc., the greater part of which were not only essentially distinct from any that are known in a recent state, but many of them are confined to certain deposits. Thirdly, that one of these formations, the Tillgate beds, contain the remains of shells, fishes, palms, arborescent ferns, turtles, gigantic lizards, and unknown quadrupeds. An assemblage of organic remains for which it is difficult to account unless we suppose that the bed in which they are enclosed was deposited by a river or lake of fresh water. Fourthly, that the chalk subsequently to its consolidation has suffered extensive destruction, the upper beds having been swept away and extensive basins formed on its surface. Fifthly, that the excavations or basins of the chalk have been filled up by a series of depositions possessing very different characters to any that preceded them, and which in some places, Isle of Wight, Paris, etc., consist of alternations of marine and freshwater deposits. Sixthly, that these newer depositions have also been broken up, and in a great measure destroyed, by an eruption of water in a state of violent commotion, a catastrophe to whose powerful agency the present form of the surface of the earth, and the accumulations of beds of gravel, sand, etc., are to be attributed. Seventhly, that it is only among these last and newest deposits, the wrecks of ancient formations, that the remains of the elephant, deer, horse, and other land quadrupeds have hitherto been discovered. Lastly, that the present effects of the ocean appear to be wholly inadequate to produce changes like those which have formerly taken place. Hence it appears that in the lapse of ages the sea alternately encroaches on and retreats from the land, and the districts it formerly occupied become the habitation of terrestrial animals and vegetables. But other revolutions succeed, the sea returns to its ancient bed, and the countries from which it retires are again fitted for the reception of their former inhabitants. Thus, as an elegant writer has remarked, to discover order and intelligence in scenes of apparent wildness and confusion is the pleasing task of the geological inquirer, who recognizes in the changes which are continually taking place on the surface of the globe a series of awful but necessary operations, by which the harmony, beauty, and integrity of the universe are maintained and perpetuated, and which must be regarded not as symptoms of frailty or decay, but as wise provisions of the Supreme Cause, to ensure that circle of changes so essential to animal and vegetable existence. Considered by Professor Buckland as identical with the Oxford clay. See Phillips' Geological Outlines, page 155. As an eminent geologist has remarked, Reverend W. D. Conybeare, Phillips' Outlines, page 144. In others it contains fragments of petrified wood, page 76. I have lately obtained several examples of fossil wood from the blue marl of Folkestone, and these so closely resemble the specimens found at Willingdon, described at page 76, that it is not improbable the latter may also belong to the lower beds of that formation. It is supposed that this sandstone did not form a continuous bed. Phillips' Outlines, page 14. The analogues of these beds appear on the opposite coast near Dieppe, where strata of sand, sandstone, and plastic clay are seen lying upon the chalk, page 266. That Great Britain was formally united to the continent can scarcely be questioned. Indeed, as Mr. Phillips observes, the many remarkable points of agreement between the opposite coasts of France and England render the supposition too reasonable to be ranked among mere hypotheses. Their separation was, in all probability, occasioned by an eruption of the sea, which washed away the connecting mass. See Geological Transactions, Volume 5, page 51. By the waters of a transient deluge. See Cuvier's Theory of the Earth, translated by Jameson, page 171. Mr. Greenough's Critical Examinations of the First Principles of Geology, page 155. Professor Buckland on the Quartz Rock, etc., Geological Transactions, Volume 5, page 544. By successive depositions at the bottom of tranquil seas. The absence of all traces of land animals and vegetables in these beds does not, however, appear to warrant the inference that the former were not then in existence. For if we suppose that after the deposition of the iron sand, the sea retired, and the surface of that formation became clothed with vegetation and inhabited by animals, may it not be presumed that if the approach of the next ocean was gradual, the advance and retrocession of its waves might destroy all traces of the land and its productions before the water covered the surface to a sufficient depth to allow of the tranquil deposition of the wheeled clay? This remark equally applies to the other secondary formations. Thus, as an elegant writer, Dr. Paris. Mysterious round, what skill, what force divine, deep felt in these appear. Were every faltering tongue of man, Almighty Father, silent in thy praise, thy works themselves would raise a general voice, even in the depths of solitary wilds, by human foot untrod, proclaim thy power.